For question 6, we're asked a vectors question. They give you two vectors in the question, vectors A and B. These are velocities, and I and J are perpendicular. So I've drawn myself a little sketch diagram here with I and J, and I've just plotted these things on, just in case that's helpful later. We're asked first to find the speed of B. So notice B is given as a velocity. In order to find the speed, all we need to do is square the components of this and square root. So we get speed equals the square root of, and it's this one, it's B, it's 15 squared plus 8 squared. If you want, you can think about it as plus minus 8 squared, but minus 8 squared is still the same thing. So if we want to do this on a calculator, we can do 15 squared plus 8 squared gives you that. So this is equal to square root 289. If we square root this, we end up with 17. 17 is our answer. We should really give it units, which is meters per second. So there's our first answer. The next bit, we're asked to find the relative speed of B from A. They use the word to, but you can use to or from. But relative to A or from A means we're starting at A and we're going to B. So this is A to B, which is plus B minus A. If you think about it, we can always go back to the origin. So it's OB minus OA. So we go back to the origin, then we go forward to B. So this is this one, 15i minus 8j. Please make sure you underline your vectors, because it's part of the vector convention. Take away 8i minus 3j. Remember, we've got a minus and a minus meeting here, but we end up with 15, take away 8, which is 7i, and here we have 8 minus minus 3, so minus 8 minus minus 3 is minus 5j. That is our relative speed. If I was to plot our relative speed on here, we go 7 minus 5, so it would be this way. For part C, we're asked to find the angle between our answer from B and I. We're asked to give our answer in degrees, correct to 1 decimal place. So what we're after is this angle here. I'm going to call it theta, because it's between the I vector, which is there, and our vector that we found there. This makes a triangle. Theta here, we've got 7 along this side, and we've got 5 on the opposite side. I know it's written here, but it's the same distance here and here. So because this is the opposite and the adjacent, we're going to use tan. Theta is 5 over 7, opposite first, adjacent second. So we get this, so we get theta equals tan minus 1, 5 over 7, so we get theta equals, if we grab our calculator, we can do shift tan 5 over 7, and it will give us an answer of 35.537, or 35.5 to 1 dp. And that's the end of the question.